The Great Pyramid of Giza holds a mathematical secret within its stones. For centuries, we have called these structures tombs, but new evidence suggests they are something far more profound. They are a global collection of geometric blueprints built by cultures separated by vast oceans and thousands of years. This video will show you the hidden language of shape and number that connects pyramids from the deserts of Egypt to the jungles of Central America. You will discover how ancient builders embedded advanced astronomical alignments and sacred ratios into their designs, creating a puzzle that challenges everything we thought we knew about early human history. How is it possible that the same complex math appears in monuments worlds apart? What does this shared code reveal about a lost chapter of human knowledge? What forgotten truth about our world is written in this ancient stone? Look at the perfect spiral of a nautilus shell or the repeating hexagons in a honeycomb. These are not just accidents of nature. They are expressions of a hidden language, a system of proportions and patterns so fundamental that it seems to be woven into the universe itself. This is sacred geometry. It is far more than beautiful art. It is a mathematical framework that ancient philosophers and builders believed was the blueprint for creation. From the thinkers of Plato's Academy to the sages of ancient India, diverse cultures identified the same shapes and ratios as manifestations of a divine order, a harmony connecting the smallest life forms to the grandest celestial movements. Key to this system are concepts like the golden ratio, a special proportion often found in growing structures, and the Fibonacci sequence, a number pattern that describes the spirals in sunflowers and galaxies alike. There are also the 5 Platonic solids, shapes that are perfectly symmetrical and were thought to represent the essential elements of the world. Why does this matter for the pyramids? Because this universal language of shape and number provides the key to understanding their design. The builders were not just stacking stones, they were embedding these cosmic principles into their work. They were using the very grammar of nature to construct their monuments. This perspective transforms the pyramids from simple tombs into profound statements, stone libraries holding a shared wisdom about the structure of reality itself. With this lens, the Great Pyramid of Giza reveals its secrets not as random measurements, but as a deliberate and sophisticated application of this ancient knowledge. This mathematical precision encoded in the Great Pyramid is so advanced it feels out of place in time. Take its core dimensions. If you take the pyramid's original base perimeter, roughly 3,024 feet, and divide it by twice its original height of 481 feet, the result is a number eerily close to pi, 3.1416. This is the fundamental constant that defines the relationship between a circle's circumference and its diameter. The builders did not just stumble upon this relationship, they deliberately designed it into the very fabric of the structure. This is not the only mathematical marvel. The pyramid's base-to-height ratio also embodies the golden ratio, that special proportion celebrated in sacred geometry. And its 4 sides are aligned to the cardinal directions north, south, east, and west, with an accuracy of less than 1/15 of a single degree. Achieving this would have required not just sophisticated surveying tools, but a profound understanding of the Earth's rotation and the motions of the stars. Look deeper inside the pyramid itself. The so-called air shafts leading from the king's chamber are not for ventilation. One points directly toward the star Sirius, while another aligns with the belt of the constellation Orion. These are not random choices, they are deliberate astronomical markers. When you combine all of these elements, a breathtaking theory emerges. The Great Pyramid may be a scale model of the Northern Hemisphere, built at a ratio of 1 to 43,200. This specific number is not arbitrary. It is also linked to the Earth's precessional cycle, the slow wobble in its axis that takes 26,000 years to complete. The pyramid is not merely a building, it is a representation of our planet and its place in the cosmos. This level of integrated knowledge, weaving together geometry, astronomy, and geography, points to a purpose far beyond a royal tomb. It was a scientific instrument carved in stone, and this raises a profound and unsettling question. If this knowledge was present in ancient Egypt, was it truly isolated there? Or was it part of a shared blueprint that somehow traveled across the globe? Across the ocean in the Valley of Mexico, the Pyramid of the Sun at Teotihuacan stands as a second geometric blueprint. Its immense base stretches for nearly 2,932 feet, a number that seems random until you measure it with the ruler its builders used. That ruler was the standard Teotihuacan unit, a length of about 32.9 inches. When you apply this ancient measure, the pyramid's design unlocks. Each side of its base is precisely 216 standard Teotihuacan units. This is not a random number, it is 6 cubed, a figure of profound significance in ancient number systems. The pyramid's height and slope then form a perfect 3-4-5 Pythagorean triangle, a fundamental geometric shape known for its perfect right angles, centuries before such principles were formally documented in the Old World. This mathematical precision was not confined to a single building. The entire city of Teotihuacan, from the long street of the dead to the precise placement of its temples, was constructed on a vast grid governed by this same unit of measurement and these geometric rules. The city itself was a geometric diagram laid out on the earth, and this diagram was aimed at the heavens. The main avenue aligns with the point on the horizon where the Pleiades star cluster makes its zenith passage, a key event in the Mesoamerican calendar. The pyramid's volume and proportions are also thought to mirror these calendrical cycles, perfectly integrating the measurement of time with the measurement of space. Here, geometry was the tool that connected the earthly realm to the cosmic order. The builders of Teotihuacan, working in complete isolation from the Egyptians, arrived at the same fundamental truths about number, shape, and the cosmos. They used a standardized unit to encode these truths into their city, creating a permanent representation of universal harmony. This parallel discovery on another continent forces a fascinating question. If two cultures with no conceivable contact both chose to express their highest knowledge through pyramid geometry, what other echoes of this ancient blueprint might we find? The bent pyramid at Dosha presents a puzzle in stone, its silhouette broken by a dramatic shift in angle. Where most pyramids rise with a single, clean line, this one changes its mind halfway up, creating a distinct bend. For a long time, this was seen as a mistake, a correction made in panic as the structure began to show signs of stress. But what if the bend was the point all along? This unique profile may be the clearest evidence we have of ancient engineers actively experimenting with sacred geometry. The lower section rises at a steep 54 degrees, a slope that creates a very specific mathematical relationship between the pyramid's height and its base. This could be an application of the Sikt, an ancient Egyptian unit for measuring slope, attempting to encode a perfect ratio. The builders then intentionally shifted to a gentler 43-degree angle for the upper section, a change that would have provided crucial stability. This was not a failure of design, but a calculated compromise between geometric idealism and physical reality. Some researchers see even deeper knowledge here, suggesting the two angles were chosen to express a relationship with the circle, perhaps even an early understanding of pi. The bent pyramid stands as a frozen moment in a grand experiment, a bridge between the earlier step pyramids and the later, perfectly smooth-sided monuments. It is a physical record of discovery, showing that the mastery of pyramid geometry was not a gift but an achievement, honed through trial, observation, and profound calculation. This spirit of architectural experimentation, this willingness to build and learn, was not confined to the Nile Valley. A strikingly similar story of iterative design was unfolding on the other side of the world, where another pyramid was being reshaped by the very ground beneath it. Far from the Nile, in the cradle of civilization between the Tigris and Euphrates rivers, another geometric blueprint rose toward the sky. The Ziggurats of Mesopotamia were not tombs but stairways to the gods. Constructed from sun-baked bricks, these massive stepped pyramids served as sacred high places, a man-made mountain designed to connect the earthly realm with the divine. The most famous of these, the Great Ziggurat of was a towering structure of 3 colossal tiers, each level painted a different color and dedicated to a specific deity or celestial power. Its core geometry was one of ascent and symbolic order. The base formed a massive rectangle, and each succeeding tier was precisely smaller than the last, creating a constant, receding ratio that drew the eye and the spirit upward. This was not just an architectural style, it was a spiritual calculation, a geometric representation of the climb from our world to the heavens. The entire structure was a carefully calibrated instrument for celestial observation. Its 3 monumental staircases converged at a single gate, an entrance that was meticulously aligned with the movements of the stars and planets. The rising of Venus, the path of the solstice sun, these cosmic events dictated the orientation of every ramp and doorway. The very bricks used in its construction followed specific ratios, ensuring both physical stability and symbolic harmony. This was a cosmic mountain, built with mathematical precision to embody a culture's entire understanding of the universe. While the Egyptians sought to mirror the hemisphere in smooth, perfect triangles, the Mesopotamians encoded their cosmology in a staircase of ascending tiers. This is the profound pattern emerging across the globe. Isolated cultures with no possible contact were all compelled to build pyramids, and each one used its own form of advanced geometry to express a shared, fundamental idea that human beings could use stone and math to reach for the cosmos. And in the dense jungles of Cambodia, one culture would take this celestial ambition to its absolute zenith, carving an entire map of the universe in stone. Deep in the jungles of the Yucatan, the Pyramid of Teotihuacan at Chichen, Itza transforms into a celestial clock. During the spring equinox, a spectacle unfolds as the setting sun casts a series of triangular shadows along the northern staircase. These pools of light and dark connect, flowing down the steps to meet the stone serpent heads at the base, creating the breathtaking illusion of a feathered serpent slithering from the heavens to the earth. This is no mere trick of the light, it is a masterwork of integrated design where the pyramid's geometry serves as a precise astronomical instrument. Each of its 4 sides has 91 steps, and when you add the single shared platform at the summit, you arrive at the perfect number of 365, one for each day in the solar year. The structure is a massive, functioning calendar carved in stone. Its 9 terraced levels are split by the grand staircases, a design that mirrors the 18 months of the Maya calendar, and its entire orientation is set with such accuracy that it marks the equinoxes with this stunning visual display. But the encoding goes even deeper. The proportions of the base and the specific angles of the staircases were calculated not just for visual drama, but to produce remarkable acoustic properties. A hand clap at the base of the stairs echoes back as the chirp of the sacred Quetzal bird. Here, geometry is not just about shape and number, it is about sound, light, and time, all woven together into a single, holistic expression of cosmic order. The pyramid is a perfect fusion of form and function, where every line and angle holds a meaning tied to the movements of the heavens. This sophisticated design philosophy, so evident at Chichen Itza, forces us to ask a practical question. How did these ancient architects, working without modern tools, achieve such breathtaking precision across continents? What common methods could possibly link the pyramids of Egypt, Mesoamerica, and the wider world? The precision of these global monuments forces us to reconsider the architect's toolkit. Imagine the immense challenge of laying out the Great Pyramid's near-perfect square base, each side over 750 feet long, using only the technology of the time. The evidence points to a suite of brilliantly simple yet effective tools. The primary instrument for surveying was likely the knotted cord, a rope with evenly spaced knots that could be stretched taut to measure distance and, more importantly, to create perfect right angles. By using a cord with knots in a 3-4-5 ratio, builders could easily form a precise right triangle, guaranteeing the square corners essential for a stable pyramid. For leveling the massive foundation, they would have used water levels, relying on the immutable fact that water always finds its own level to create a perfectly flat plane across acres of uneven ground. Citing instruments, perhaps simple notched poles or the more advanced Merkit, allowed them to track the passage of stars with astonishing accuracy, locking their structures to the cosmos. In Egypt, this practical geometry was codified into a system called the Ziggurats, a standardized measure for a pyramid slope that unified base length and height into a single, repeatable ratio. This was not just math for math's sake, it was a sacred craft. The act of establishing a foundation was a ritual, aligning a building with the cardinal directions was an act of cosmic order, and squaring a circle in stone was an attempt to unite the earthly and the divine. These builders were master geometers, part of a learned guild who possessed and guarded a deep understanding of number, proportion, and the physical world. Their ability to translate these abstract ratios into mountains of stone with such consistency across continents is one of history's greatest intellectual achievements. This shared geometric language suggests a profound possibility that these cultures were not just building similar shapes, but were all tapping into the same fundamental well of knowledge about the universe. And if this knowledge was so universal, then the patterns we see are not mere coincidence, but a conscious repetition of a primordial code for creation itself. This same divine proportion, phi, echoes in the very layout of sacred spaces. The Great Pyramid of Giza encodes it in the relationship between its slant height and its base. The Pyramid of the Sun at Teotihuacan may hold it within the proportions of its massive platform. Even the arrangement of the three main pyramids at Giza has been scrutinized by researchers who find potential geometric relationships based on this special number. It appears too often in too many isolated locations to be mere chance, so we are left with a compelling question. Were these ancient architects intentionally designing with this ratio in mind, aware of its unique harmonic properties? Or were they intuitively guided toward it by following the same proportional systems they observed in the natural world, in the curve of a nautilus shell or the spiral of a galaxy? The persistent recurrence of phi suggests it was more than a building technique, it was a philosophical statement. These cultures, separated by continents and millennia, all perceived this ratio as a fundamental ingredient in the recipe of the cosmos. By building it into their most enduring monuments, They were attempting to anchor their sacred spaces to this universal order, creating a resonance between the earthly and the divine. This shared pursuit of a cosmic blueprint points toward another mathematical constant, one even more famous, whose presence within these ancient stones is perhaps the most baffling of all. The presence of pi in a square-based pyramid is a mathematical marvel that feels almost like a paradox. This is most famously observed in the Great Pyramid, where the base perimeter is virtually equal to the circumference of a circle with a radius equal to the pyramid's height. This is the ancient problem of squaring the circle, a geometric puzzle that seeks to create a square with the same area as a given circle using only a compass and straightedge. The pyramid's design seems to offer a three-dimensional solution in stone, but this idea was not confined to the sands of Egypt. Some analyses of the Pyramid of the Sun at Teotihuacan suggest its dimensions, when divided in a specific way, also produce an approximation of pi. How could cultures with no apparent contact stumble upon the same sophisticated mathematical relationship? The answer may lie not in shared blueprints, but in shared observation. An ancient engineer rolling a drum or a wheel might have noticed that it traveled a distance roughly 3 and a little more times its own diameter in one full rotation. This empirical discovery that a circle's circumference is always just over 3 times its diameter could have been elevated from a practical observation to a sacred principle. Encoding this constant into a pyramid was more than a technical achievement. It was a profound philosophical act. The square base, firmly planted on the earth, represented the material world and the 4 cardinal directions. The circle, implied by the constant pi, represented the celestial realm, the eternal cycles of the sun and stars. By uniting them in a single structure, the builders were creating a symbol of cosmic harmony, a bridge between the world of humankind and the perfect, infinite order of the heavens. This was not just architecture, it was a spiritual equation rendered in stone. This conceptual leap from simple measurement to profound symbolism reveals a mind that saw mathematics as the language of the universe itself. And this language was not only used to describe the earth, but to meticulously map the sky above. The arrangement of the Giza Plateau is a map of the heavens written on the desert floor. According to the Orion correlation theory, the 3 Great Pyramids are positioned to mirror the 3 stars of Orion's belt, with the Nile River itself representing the Milky Way. This celestial mimicry is not unique to Egypt. At Teotihuacan, the Grand Avenue of the Dead and its major pyramids are laid out in a pattern that some researchers argue reflects the relative distances of the planets in our solar system, a staggering feat of astronomical modeling. These are not vague resemblances, they are precise geometric transcriptions of the night sky as it appeared millennia ago. This points to a knowledge that goes beyond simple stargazing. It suggests an understanding of precession, the slow, grand wobble of the Earth's axis that completes its cycle every 26,000 years. The pole star is not a fixed point. Over centuries, it changes. In the age when the Great Pyramid was built, the star Thuban in the constellation Draco held that position. And remarkably, one of the narrow shafts leading from the king's chamber is aimed directly at where Thuban would have been visible, a frozen line of sight to a forgotten pole. By encoding these slow, majestic cycles into their monuments, the builders created something more permanent than any written record. They built eternal observatories, stone calendars that would track time for thousands of years. The specific angles of a pyramid's slope, the precise orientation of its sides, these were not just architectural choices. They were deliberate calculations meant to capture a specific moment in the great cosmic dance. The geometry of the pyramid becomes a time capsule, a snapshot of the celestial sphere at a fixed epoch. This reveals a worldview where the earth and the heavens were not separate realms, but two halves of a single harmonious whole. To build on earth was to build in the sky, and to understand geometry was to understand the very language of the cosmos. But what if a tomb was merely its secondary function, a later addition to a structure with a far more profound purpose? The sheer precision of these geometric forms points to their use as sophisticated instruments, tools for interacting with the very fabric of the world. Some researchers propose that the unique shape of a pyramid can act as a lens for natural energies, focusing subtle electromagnetic or telluric forces that flow through the earth. While this remains a speculative theory, it invites us to consider the pyramid not as an inert pile of stone, but as a dynamically interacting form. More tangibly, these structures were masterful timekeepers. Their shadows, cast by the moving sun, functioned as giant sundials, marking the solstices and equinoxes with unwavering accuracy. They were calendars on a colossal scale, ensuring agricultural and ceremonial cycles were perfectly synchronized with the cosmos. Inside, the architecture reveals another layer of function. Certain chambers, like those found in Mesoamerican sites, possess remarkable acoustic properties. A whisper in one corner can be heard clearly across the room, suggesting these spaces were designed for sonic rituals, where chanting or music was amplified to alter consciousness and connect with the spiritual realm. The construction process itself, governed by sacred geometry, was a form of spiritual technology. Each perfectly laid stone, each precisely calculated angle, was an act of aligning the human world with cosmic order. By permanently encoding mathematical constants and celestial ratios into the landscape, the builders created eternal temples of knowledge. These were not monuments to death, but living libraries and instruments designed to help humanity comprehend its place in a vast, harmonious universe. This expanded view transforms our understanding of their purpose, and it inevitably leads us to wonder about the brilliant, enigmatic minds who conceived of such a unified vision for stone. These master builders were far more than simple laborers or stonemasons. They were the intellectual elite of their time, a specialized class of architect priests who held a sacred and closely guarded knowledge. This was not a trade one learned casually. It was an esoteric tradition passed down through generations, blending practical engineering with spiritual wisdom. They understood the language of the stars, the properties of materials, and the invisible rules of geometry that govern the natural world. Their role was to act as intermediaries, translating cosmic order into physical form, and their monuments were the ultimate expression of this sacred duty. The question of how this knowledge spread across the globe presents two compelling possibilities. The first is independent discovery. Perhaps each great civilization, through millennia of patient observation of the heavens and the earth, independently unlocked the same mathematical truth. They saw the same spirals in shells, the same ratios in the human form, and the same cycles in the stars, and each arrived at similar conclusions about the fundamental geometry of creation. This would be a powerful testament to the universal capacity of the human mind. The alternative is a shared source, a tantalizing theory that a single, highly advanced but now lost civilization possessed this knowledge and disseminated its core principles across the world. This could have been accomplished by ancient seafarers traveling forgotten trade routes, carrying not just goods but ideas, their knowledge woven into shared mythologies and symbolic stories that were adapted by each culture they encountered. Whether through independent genius or a forgotten teacher, the result is the same, a consistent application of sacred geometry that transcends culture and creed. The master builders of Egypt, Mesoamerica, and Mesopotamia may never have met, but they spoke the same silent language of shape and number. They demonstrated that abstract concepts like pi and the golden ratio could be made permanent, could be carved into the very landscape as a testament to humanity's quest for understanding. This mystery of their connection is what makes these structures so endlessly fascinating. They are not just piles of rock, they are the frozen thoughts of history's greatest minds. And today, we are using our own advanced tools to listen to what these stones have been trying to tell us for thousands of years. These silent stone giants are finally being heard with a clarity we never thought possible. The tools of the 21st century, like laser scanning and photogrammetry, are acting as digital interpreters, allowing us to measure these monuments with a precision that would have astounded their original surveyors. LiDAR technology, which uses laser pulses to map surfaces in 3 dimensions, can create a point cloud model of an entire pyramid complex, capturing every subtle indentation and angle down to a few millimeters. This is not just about creating a pretty picture, it is about gathering raw, unbiased data on a scale never before achievable. With these hyper-accurate digital twins, researchers can now perform rigorous statistical analyses on the very ratios and angles we have long speculated about. They can test with mathematical certainty whether the golden ratio is truly encoded in the slope of a Mexican pyramid or if pi is intentionally woven into the base of an Egyptian one. The computer can run millions of calculations, simulating the path of shadows across a staircase over thousands of years, or digitally rebuilding a collapsed capstone to understand its original geometric intent. This process is like digitally cleaning away centuries of erosion and damage, peeling back the layers of time to see the pristine, intended form of the structure. The results are both confirming and correcting our understanding. Some long-cherished theories, when subjected to this cold, hard data, have been revealed as wishful thinking or the result of accumulated measurement errors. Others, however, have been validated with a new and powerful authority, proving that the builder's geometric knowledge was even more sophisticated than we imagined. This empirical approach is our most powerful tool for separating the compelling signal of intentional design from the random noise of coincidence. But as the data pours in, it presents a new and profound challenge. We now have the numbers, but the ultimate question remains: what do these perfect ratios truly mean? Were they a spiritual code, a scientific textbook, or something else entirely that we have yet to comprehend? The sheer number of geometric coincidences across the globe does invite a healthy dose of skepticism. After all, if you measure any large structure from enough angles, you are bound to find some numbers that look significant. This is a recognized psychological phenomenon. Our brains are wired to seek out patterns, even where none exist. Critics rightly point out that not every proposed alignment holds up to scrutiny. Some rely on measurements from a pyramid's ruined and weathered state, rather than its original, pristine dimensions, which can lead to very different conclusions. And it is true that a culture might choose a pyramid slope for purely practical reasons like stability, with any resulting mathematical harmony being an unintended byproduct. This is where we must be most careful, separating the clear signal from the noisy static of coincidence. The most compelling evidence for intentional design, however, lies in the repetition of specific, complex ideas. Finding the golden ratio in one pyramid could be chance, finding pi in another could be luck, but when you see the same few constants, pi, the golden ratio, Pythagorean triangles, and precise astronomical alignments, all appearing together in multiple, unconnected cultures, the odds of that being random begin to vanish. The true strength of the argument is not in any single measurement, but in the integrated system. It is the combination of a pyramid's base perimeter encoding a circle's circumference while its internal shafts point to specific stars and its overall layout mirrors a constellation. This multi-layered encoding, this weaving together of geometry, astronomy, and geography, feels less like a happy accident and more like a deliberate, sophisticated language. A balanced view requires us to hold both possibilities, acknowledging where pattern seeking may lead us astray, while also recognizing the profound consistencies that defy simple explanation. This critical lens is not a dismissal of the mystery, but a way to refine it, to focus on the evidence that is most robust and most difficult to explain away. And this very process of questioning what was intentionally designed forces us to confront an even deeper loss, the silence that followed the end of these great building traditions. We are trying to reconstruct a symphony from a few scattered notes, the mathematical papyri and rare codices that have survived the centuries, like the Rhind papyrus from Egypt, offer us crucial clues. They are like a student's exercise book, showing us the basic formulas and problems these cultures could solve. Yet they almost certainly represent just the rudimentary principles, the introductory lessons, not the advanced, esoteric knowledge reserved for the master builders and priestly elites. Think of the legendary Library of Alexandria, a repository said to hold the collective wisdom of the ancient world. Its destruction was an intellectual catastrophe, a fire that consumed untold thousands of scrolls containing advanced geometry, astronomy, and engineering principles we can now only guess at. And beyond written records, we have lost the living tradition. The master architect did not teach his apprentices through textbooks alone, but through hands-on guidance, whispered secrets, and decades of practical experience. That oral chain of knowledge is broken forever, its content vanished into silence. This profound loss means our modern decoding is an inherently imperfect process. We can measure the Great Pyramid and identify the mathematical constant pi in its proportions, a discovery that feels brilliant and conclusive. But what did pi mean to them? Was it a mere building tool, or was it a sacred number representing the journey of the soul, a symbol of the divine transition from the earthly square to the celestial circle? We see the geometric pattern clearly, but the spiritual and philosophical meaning behind that pattern may be completely lost to us. The strange chambers above the king's chamber, known as the relieving chambers, were they simply structural, designed to distribute immense weight? Or did they serve another, more ritualistic purpose tied to their specific dimensions and alignment? We may never truly know. This acknowledgement is not a defeat, but a humbling recognition of the scale of this ancient achievement. Their intellectual world was vast, and we are only exploring its shorelines. This is precisely why every new discovery, whether from a hidden chamber revealed by cosmic rays or a fresh analysis of laser scan data, holds the potential to be revolutionary. It could be the key that finally unlocks not just how they built, but why. The silence of the past is not empty, it is full of questions waiting for an answer. These geometric codes were not confined to stone, they lived in the very stories people told about the beginning of the world. The myths of pyramid-building cultures are filled with the language of sacred geometry, offering a narrative key to their architectural choices. In ancient Egypt, the god Ptah was believed to have conceived the entire cosmos within his heart before speaking its physical form into existence. This is a profound geometric metaphor, the entire universe beginning as a single, dimensionless point in the mind of a god before expanding outward into the shapes and structures of reality. A similar pattern of iterative design appears in the Maya Popol Vuh, where the gods made several failed attempts at creating the world and humanity before finally succeeding. This is not so different from the architectural experiments we see at Dosha, a narrative of trial and error that mirrors the process of perfecting a geometric form. Perhaps the most universal geometric concept in these myths is the axis mundi, the world mountain. This was understood as a central pillar connecting the heavens, the earth, and the underworld, a single point of alignment for the entire cosmos. The pyramid is the physical embodiment of this idea, its peak a man-made summit designed to touch the divine. This symbolic function explains the obsessive focus on cardinal alignment, as the pyramid was meant to be the stable, eternal center of a turning world. Then there is the ancient puzzle of squaring the circle, a challenge that appears both in the proportions of the Great Pyramid and in the symbolic language of these cultures. The circle represented the celestial, the infinite, and the perfect motion of the heavens. The square represented the earthly, the material, and the four fixed directions of our world. To unite them in a single structure was the ultimate act of sacred engineering, an attempt to bring cosmic perfection down to earth and anchor it permanently in the landscape. These creation stories are far more than fanciful tales. They are the philosophical and cultural context for the mathematics. They tell us that the builders were not just calculating slopes and bases, they were participating in the original act of creation itself, using geometry as a divine language to build their own world mountains and access points. The myth provides the why, while the monument provides the how, two halves of a single, profound understanding of a universe built on number, shape, and harmony. Perhaps the most controversial idea about these structures is that the pyramid itself is a machine. This theory suggests the unique geometry of the shape can interact with natural forces in ways we are only beginning to understand. Some researchers propose that a pyramid acts as a passive resonator, focusing subtle electromagnetic fields or even hypothetical scalar waves. Others point to telluric currents, the slow-moving streams of electrical energy that flow deep within the Earth's crust, suggesting the pyramid's mass and shape could channel these forces. There are anecdotal accounts of experiments with small-scale models where organic matter like food seemed to dehydrate without rotting, or where razor blades placed inside allegedly regained their sharpness. Yet, these effects are notoriously difficult to replicate in rigorous, controlled scientific settings, leaving the door open for both skepticism and fascination. The very materials chosen by the builders add another layer to this mystery. The massive granite blocks in the king's chamber of the Great Pyramid, for instance, contain a high percentage of quartz crystal. Quartz is known for its piezoelectric properties, meaning it can generate a small electrical charge when subjected to mechanical pressure, such as the immense weight of the stones above or even the subtle vibrations of the earth itself. Could the entire structure have been designed to harness this energy? While mainstream science remains cautious, citing a lack of reproducible evidence, the persistence of these theories is understandable. They attempt to answer a fundamental question that conventional explanations often overlook. Why would cultures across the globe repeatedly choose such an energetically and logistically demanding form if it served a purely symbolic or funerary function? The energy hypothesis, whether it is ever proven, forces us to expand our imagination. It challenges us to consider that the ancient master builders were not just geometricians and astronomers, but perhaps also pioneers of a forgotten natural philosophy, one that understood the hidden energies of the earth and sought to build instruments to commune with them. This line of inquiry remains a frontier, pushing the very boundaries of how we interpret ancient technology and its potential purposes. This same spiral of numbers that guides the growth of a sunflower appears to be etched into the desert floor at Giza. The Fibonacci sequence, that simple progression where each number is the sum of the two before it, shows up in the very spacing of the pyramids. If you measure the distances between the centers of the three main structures, Khufu, Khafre, and Menkaure, some researchers find a relationship that closely mirrors the Fibonacci numbers 5, 8, and 13. This is not a perfect modern application, but the pattern is strikingly present, a mathematical echo of a pinecone's design found in one of humanity's grandest projects. This recursive sequence is a blueprint for how living things expand and organize themselves, a principle of dynamic growth. By incorporating it into their monumental layout, the ancient architects were doing something profound. They were not just placing tombs, they were infusing their static stone city with the inherent vitality of the natural world. The complex became more than a collection of buildings, it was a symbolic organism, its growth governed by the same universal mathematics that shapes a galaxy or a seashell. This deliberate blurring of the line between the organic and the constructed suggests the builders saw no separation between the laws of nature and the works of humankind. Their ambition was to create architecture that was truly alive, resonating with the fundamental frequency of creation itself. And if the very arrangement of the pyramids was meant to mimic the growth patterns of nature, it forces us to look closer at the ground they chose to build upon. What invisible qualities of the earth itself did these master builders sense, and how did the specific energy of a location become part of their grand geometric design? The ground beneath these monuments was as carefully chosen as their geometric form. This ancient art of placement, known as geomancy, viewed the earth as a living body crisscrossed with invisible pathways of energy, often called ley lines. Proponents of this theory highlight a stunning pattern where sacred sites from the pyramids of Giza to the temples of Cambodia appear to align along straight tracks for dozens, sometimes hundreds of miles. These are not random placements. The Giza Plateau itself sits at the precise center of the Earth's landmass, a location that would have been considered a powerful nexus, a focal point of the planet's vital forces. In this worldview, the pyramid was not an isolated structure. It was the final, crucial component in a circuit of energy. Its perfect geometry was designed to act as a lens and an amplifier, harnessing these terrestrial currents and stabilizing them into a coherent field. While modern science does not recognize ley lines as measurable energy channels, the undeniable fact remains that ancient builders consistently selected sites of profound geographical significance. They positioned their pyramids on prominent hilltops, at the confluence of mighty rivers, or in direct alignment with specific mountain peaks. This was a holistic science where geography, astronomy, and geometry were inseparable. The choice of location was the first sacred act, the foundational geometric decision that determined everything that followed. It completed a design philosophy where a structure was not merely placed upon the land, but was consciously woven into the very fabric of the earth and sky. This deep integration raises a final, compelling thought. If the builders were so meticulous in their placement, what other invisible relationships might we have missed? Connections that tie these global monuments into a single, silent network spanning the entire planet. This ancient puzzle of squaring the circle was far more than a mathematical game. It was a spiritual quest to unite two seemingly irreconcilable worlds, the perfect, infinite realm of the heavens symbolized by the circle, and the ordered, material world of humankind represented by the square. The Great Pyramid of Giza stands as the most famous architectural solution to this eternal problem. Its base perimeter is virtually identical to the circumference of a circle, drawn with a radius equal to the pyramid's own height. This was not a coincidence, but a deliberate, three-dimensional equation carved in limestone. For the Egyptians, this geometric union was the very essence of Maat, the cosmic principle of truth, balance, and order. The pharaoh, through this structure, became the living link holding these two realms together, ensuring the harmony of the universe itself. We see this same symbolic language echoed across other pyramid cultures. The square base almost universally anchors the structure to the four cardinal directions, or to the four classical elements of earth, air, fire, and water. The ascending sides then converge at a single apex, a point that represents the fifth element, the spirit, or the unifying principle that brings all things into a coherent whole. This is why the pyramid was never merely a tomb or a temple. It was a cosmological engine, a permanent model of a perfectly balanced universe. Its geometry was a philosophical argument made in stone, asserting that humanity could, through intellect and sacred art, build a bridge to the divine. The mathematics gave the symbol its precision, but the symbol gave the mathematics its soul, transforming raw calculation into a profound statement about our place in the cosmos. The silence inside the Great Pyramid is not truly silent. It is a space tuned to a specific resonance. Step into the Grand Gallery, and the very architecture seems to hum with an unseen energy. Its towering, corbelled walls and narrow, steeply ascending passageway create a unique sonic environment. Modern experiments have revealed that this space, along with certain chambers, can resonate at low frequencies, particularly around 110 Hz. This specific frequency is known to alter brainwave patterns, potentially inducing states of deep focus or heightened awareness. It is as if the chamber itself was designed not just to be seen, but to be heard and felt on a physiological level. This principle extends far beyond Egypt. At the Maya Pyramid of Kukulkan at Chichen Itza, a simple hand clap at the base of the grand staircase does not return as a simple echo. It transforms into a chirping sound, a perfect mimic of the sacred Quetzal bird, a creature deeply woven into their spiritual cosmology. This is not an acoustic accident. It is the result of the precise geometry of the stair steps, each one acting as a sound diffractor, scattering the sound waves in such a way that they interfere with each other to produce that specific, symbolic tone. This conscious interplay between architectural form and sound wave behavior is a science we now call cymatics, the study of how vibrations manifest in physical matter. The ancient builders likely understood these principles through generations of intuitive observation and experimentation. They learned that by shaping stone in a particular way, they could also shape sound, curating an immersive sensory experience within their sacred spaces. The geometry was not merely visual, it was vibrational. It was a tool to orchestrate an environment where ritual chanting, musical instruments, or even the rhythm of breath could be amplified and transformed, guiding participants into altered states of consciousness. This multi-sensory design reveals a holistic vision of sacred architecture, one that engaged sight, sound, and the very vibrations of the body to connect the individual with the cosmic order. The stones were not just arranged, they were tuned. The same perfect pyramid form could be a celestial ramp in one culture and a world mountain in another. This is the power of the cultural lens. For the ancient Egyptians, the smooth, gleaming sides of their pyramids were a physical representation of the rays of the sun, a divine ladder upon which the soul of the pharaoh could climb to join the eternal stars. This idea was deeply rooted in their creation myth, connected to the sacred Benben stone, the primordial mound that was the first thing to emerge from the waters of chaos at the dawn of time. Their pyramid was a recreation of that first act of creation, a perfect geometric form designed for a singular, transcendent journey. Now travel across the world to the jungles of the Maya. Their pyramids rose as massive, stepped platforms. These were not smooth ramps to the sky, but symbolic sacred mountains, the Witsob. Each tier represented a different level of the cosmos, and the grand staircases were not for the dead, but for the living. They were stages for elaborate public rituals where the ruler, often in a trance state, would communicate with ancestors and gods, mediating between the earthly realm and the spirit world. The geometry was the same, a base ascending to a point, but the story it told was entirely different. In Mesopotamia, the massive Ziggurats took this idea of ascent even further. They were explicitly called stairways to heaven, but this was a journey reserved for the priests alone. The common people would only see the base, while the elite would climb the monumental staircases to perform rites at the summit, literally reaching closer to the divine. The underlying mathematical principles of these structures, their precise proportions, their celestial alignments, and their harmonic ratios, show a stunning parallel understanding of universal geometry. Yet the cultural narrative, the human meaning poured into that geometric vessel, was uniquely tailored to each society's beliefs, its political structure, and its relationship with the cosmos. This cultural diversity is not a footnote, it is a central insight. It prevents us from flattening this global phenomenon into a single, simplistic explanation. The pyramid was a versatile and powerful symbol, a blank canvas upon which each civilization painted its own deepest understanding of existence, proving that the same universal language of shape can be used to tell 1,000 different, equally profound stories. We stand before these monuments not as isolated riddles, but as a single, magnificent tapestry. The golden threads of geometry are woven seamlessly with the silver strands of astronomy, all bound together by the vibrant colors of cultural symbolism. This was never about one perfect number or a single star alignment. The true genius lies in the synthesis, the way these ancient architects combined the pie in a pyramid's perimeter with the shaft pointing to a pole star, while its very shape embodied a creation myth. It was a unified system of knowledge, a holistic science where math, myth, and the movement of the heavens were seen as different expressions of one underlying cosmic order. The pyramid was their ultimate expression of this unity, a single structure that could function as a calendar by tracking shadows, an observatory through its alignments, a philosophical statement by squaring the circle, and a resonant temple through its acoustics. This integrated vision points to a profound pattern in human history, a recurring impulse to use the most durable materials and the most elegant mathematics to build a mirror of the universe itself. They looked at the chaos of the world and sought to impose harmony, to create permanent anchors of understanding in a changing world. Decoding their hidden language, then, is about more than solving an architectural puzzle. It is the recovery of a lost chapter in the story of human thought, one that speaks to a deep, cross-cultural yearning to find our place within the grand design. This integrated perspective finally allows us to see the big picture, not as a collection of coincidences, but as a chorus of different cultures all singing the same fundamental song about a universe built on number, shape, and harmony. And this realization inevitably brings us to a final, personal reflection. What does this chorus from the ancient world mean for us, here in the modern age with all our own technology and knowledge? This journey through the language of stone and star reveals a startling truth about our ancestors. They were not primitive tomb builders, but master scientists and philosophers who spoke a universal dialect of form and number. We have traced the same elegant constants, from the pi-encoded slopes of Giza to the calendrical steps of Chichen Itza and the cosmic stairways of Mesopotamia. This consistent application of advanced geometry was a conscious effort to build bridges between the human world and the cosmic order. While countless mysteries remain, the evidence points overwhelmingly toward a purposeful, intelligent design rooted in a profound observation of nature. These silent stone sentinels challenge us to expand our definition of history itself, to recognize the profound intellectual achievements that flourished long before our modern era. The real treasure concealed within these structures is not gold or jewels, but something far more enduring. It is knowledge, It is a legacy of geometric wisdom that continues to inspire awe and ignite inquiry thousands of years later. Let this exploration be a beginning for your own curiosity. I encourage you to research further, to visit these incredible sites if you ever have the chance, and to share your own thoughts and theories in the comments